Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 4 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 11. Container with most water. So let's read the problem statement. You are given an integer array height of length n, right? So this height array is given to us and length is nothing but n here. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 to I, height of I. So here simply means here we have 1, right? So 1 means 0 to 1 like this, 0 to 1. So this 0 to height of I, 1. This 8 means 0 to 8. So that's the meaning of this point. Okay, I, 0 to I, height of I. So we have to find the two lines that together with the x-axis form a container such that the container contains the most water, right? So we have to find out the most water that a container can hold, right? So let's say this is the width of the container and this is the height of the container, right? So formula is nothing but how we calculate the area of this container. That is nothing but a rectangle or it can be square. So you are just going to write area as width into height. That's it. This is a formula. So we have to return the maximum amount of water a container can store, and notice that you may not slant the container, right? So now let's understand this problem statement with an example here. So this is your example, right? So here, okay, now it's clear. So here one, then this building height is 8, then 6, then 2, 5, 4, then 8, then 3 and 7, right? Okay, and here if I just give the indexing here, this is nothing but a 0 index. Okay, or if you want to show it in number line, so you can say this is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, right, on number line. But here if you want to show it in indexing, so you can say this is nothing but 0 index, 1 index, 2 index, 3 index, 4 index, 5, 6, 7 and 8, like this. All right, so now here if you can do one thing, right? So you can solve this problem using brute force also, right? So in brute force, what you are going to do, you are going to fix this building first, right? So this building is having height 1, then you are going to check all other buildings. So your I is going to be fixed here, then this is your J, let's say, right, for very first time. So among these two buildings, first width is nothing but this area, that is nothing but 2 minus 1 is 1, right? So width is 1 right now, and height is nothing but the minimum among these, right? So minimum among these is nothing but 1 or 8. Minimum is 1, right? So height I'm going to take 1. Why 1? Because this is the only area I can, in which I can store the water, right? This is the only area. So there, this area is nothing but the minimum height among these two, right? So if I do this, so here my area comes out for this region is nothing but width into height, that is nothing but 1, right? This is done. Same way, now let's say my J is moving to this position. Now my J is here, so among them again minimum height is 1 only, so this area I have to calculate. So here 3 minus 1, width is 2, right? Width is 2 and height is 1, so area is 2 right now for this one. Then I move my J here, then this area I have to check, right? Minimum among these two height and this. Same way, right, for this building, then this, okay. When my J is going to move here, then this area I have to calculate. Then when my J is going to move here, then this area I have to calculate. When my J is going to move here, then this area I have to calculate. So I'm calculating the area step by step, right? So once this is done, then after that I'm going to take this as my I, then again I'm going to start my J from here, then this first, right? Then this is going to be the new area that I need to find. Then this is the area that I need to find when my J is here. Then this is the area that I need to find. Same way, then this is the area I need to find. right? And side by side I will keep track of the max area, right? So here what I'm doing, I am fixing my I here, then I'm checking for all the j's and calculating the area. Then my I is moving forward, then I'm starting from my j from the next pointer like this. Then I'm moving my I here, then starting my j like this. Okay, so here if you see, in this case my time complexity is going to be O of n square, because I'm running two loops, right? And right, square. So but here if you see the constant, so n is nothing but the height dot length, and n value is from 2 to 10 to the power 5, right? So here if I'm my loop is running n square, that is nothing but, so here 10 like this, right? So definitely you are going to get the time limit exceed error, right? Oh, 10 power 10, right? So you will get the time limit exceed error in this case, and this is the height 0 into 10 to the 4, right? So definitely we can't pass our solution of n square, right? So let me show you the solution of this brute force. So here see, 59 test cases passed out of 65, right, in total, but for few we are getting this time limit exceed error. So here what we are doing, so height we are taking first, what is the total length of this height array n, then area starting from 0, then I'm running one loop I loop, right, which is running of n times, and inside this also I'm running one j loop which is starting from I plus 1. So this loop is also going to run of n time. Then here I'm calculating width as j minus I, height as nothing but math dot min of height at I and height at j, right? And then I am calculating the area. So math dot max of area, whatever the previous calculated area, and now the new area w into h. So in the end I'm returning area, right? So very simple approach this brute force, but only issue is time complexity is of n square. So now we need to see how we can solve this problem using optimal approach. So let's discuss that. All right, in optimal approach what you need to do, you need to take the two pointers. So let's say your left is here and your right is here, right? So left is at 0 index and right is at 8 index. So now these two are the buildings that I'm taking, right, as of now. So among them, if you just calculate the width is nothing but r minus l. So r is nothing but at 8 index, l is at 0 index, so you are going to say 8 is the width, and the height is nothing but a minimum height among this, right? So because in this area only I can store the water, right? So among them minimum is nothing but 1, right? So height is 1, so area that I'm going to get is 8 as of now, right? 8 is the area. Now after that tell me my left is here, right? Endpoints, right? These two are the endpoints. Left is here, r is here. Now after that, if I, this is the bigger area, right? This is the width that I'm taking as of now. Now after that, let's say if I shrink this, right? So if I shrink this, so definitely if I include this building, right, this smaller building, then I will get the less area only, right? I will get the less area only. Why? So let's say this is the building, right? And here let's say I take this as my R now, and this same as my L. So now if I just see this area, so now my area is going to be just first of all, width is nothing but 7 right now, right? Width is nothing but 7, and height is 1. So my area is reduced, right, if I'm taking this building of smaller height, right? Because here previously width was bigger, now it is smaller, right? So from here only I'm starting, okay, just for your clear understanding, from here only I'm starting. For this was the building first, bigger building here, now here is some building, right, until here only, but I'm including the smaller one. So if I'm including the smaller one, my height is always going to depend on this one only, right? Clear? But my width is shrinking. So here what I'm going to do, instead of moving my R pointer back, in this case I am going to move my L pointer. So here, out of this L and R, which building is smaller? Smaller building is this L1, right? This building is smaller. So now in the next stage what I'm going to do, I'm going to move this L here. So now if I move this L here, now my L is here and my R is here. So now I have to calculate the area. So area is nothing but in this case, first of all, width is nothing but, if I just write the indexing here, or you can refer this, right? So here 1 and here 8 minus 1. So 8 minus 1 is nothing but 7 is the width, and height is a minimum among them. 7 is the minimum. So 7 into 7, output is 49. So 49 is the width, right? Okay, 49 is the width as of now, right? Now my L here. Now among them, which building is smaller? Which building is smaller? This R is smaller, right? This building is smaller, right? So now I'm going to shrink this. So now my R is moving here, right? My R is moving here. So now I have to check this area, right? This area. So this area is also going to be smaller, right? So now again, which building is smaller? This R is smaller. So I'm going to take this now. So if my R moves here, then I have to take this area. So now in this case, both the buildings are of same length, right? Both the buildings are of same length, right? So now what I'm going to do, I'm going to just reduce this R. So my R reaches here. So now when my R reaches here, definitely this area is smaller, right? And after that I move R here, then again, then here if I move R here, then this area here, if I move my R here, then this area I have to calculate, right? So in the end, my L is going to become equal to R, then I have to stop. So here if you see, L is taking care of these two and R is taking care of all these step by step, right? So I'm just iterating over all the elements in my array only once, right? So if I'm iterating over all the elements in my array only once, so in that case my time complexity is going to be O of n, right? So in this way we can solve this problem, right? So very simple. So here I'm just going to move the pointer pointing to the shorter line. So I'm going to move that, right? And if the heights of two buildings are same, then I'm always decrementing R only, right? Okay, and I hope that you guys are clear. First n is nothing but height dot length, and then after that you have to take two pointers. Left is nothing but at 0 and right is nothing but at n-1, you can say, and you can take area and set it to 0 initially, and then after that you have to update your you have to take two pointers, right? So left is less than equal to right, and here first of all you have to calculate the width, right? So width, how you're going to get width is nothing but right minus left, and how you're going to calculate the height is nothing but the minimum among these two buildings. So math dot min of height, here you have to pass left, and here you have to write height, and here you have to pass right. So this way you are going to calculate the height, and then you have to check here if height. Okay, first let's calculate the area as well side by side. So area is nothing but, you can say, math dot max of previous calculated any area that we have, or W into H, right? So this is how you calculate the area. And here I told you that if height of left is smaller than height of right, so in that case just do one thing, move left plus plus, else you have to just simply decrement your right, that's it. And in the end you have to simply return area. Now let's run it and see if the code will try to fix that. So see, all the test case has been instructed, right? Now let's submit it. So see, our solution is empty, right? And the time complexity for this problem is nothing but O of n. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.